Good morning. Today is February 17th. It's Tuesday. The assignments for IXL today is in section I, proportional relationships. Today, the goal is to get through sections 4, 5, and 6. So those are the sections I'm going to be going through with you in this video. We're going to go ahead and click on section 4 and just talk through what we're doing. This is very similar to what we did yesterday on Monday. Here's an example of what we're doing. Ezra is finding the perimeter of different sized regular pentagons. There is a proportional relationship between the side of the regular pentagon in inches, x, which is always on this is the x-axis, and the perimeter of the regular pentagon in inches, y, and then y always goes on our vertical y-axis. So we have this graph set up with the side length of the pentagon in inches on the x-axis on the bottom and the perimeter in inches going up the y-axis on the side, going vertically. So the question that you are going to be asked is, what is the constant proportionality? So they're asking how many inches in perimeter per each inch in side length. So for every 1, how many inches in perimeter? So every 1 inch in the side length equals 5 perimeter inches. So let's just double check and see if that's a proportional excuse me, a proportional relationship. So 2, it intersects at 10. Yep, so it goes up 5 inches in perimeter for every inch on the sides. So the easiest way to do it is go to 1 and go on up to the first point that it intersects, and it's going to be 5 inches in perimeter per inch in side length. Here's another one. Zane loves to bake blueberry muffins for his friends and family. There's a proportional relationship between the volume of flour Zane uses in cups, which will be our X, and the number of muffins he bakes, which will be our Y. So along the bottom, we have the cups of flour that are proportional to the amount of muffins he bakes. What is the constant of proportionality? Write your answer as a whole number or decimal. So muffins per cup of flour. So we're going to go to 1 cup. We're going to go up to where this line intersects the 1 line. We're going to go up, 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 5. For every 1 cup of flour he uses, Zane bakes 5 cups of muffins. Same here. Chalk Arcade has Emma's 2 favorite things, a chocolate shop and an arcade. Not only that, but Chalk Arcade's loyalty program rewards Emma with a free game token every time she buys chocolates. We had this scenario earlier, I think, in our video yesterday. So there is a proportional relationship between the number of chocolate Emma buys, as represented on our x-axis, and the amount of tokens that she gets, as represented on our y-axis. What is the constant of proportionality? Write your answer as a whole number or decimal. So for every 1 chocolate, she gets 2 free tokens, because this is intersecting with our 2 line. So we go to where the 1 meets up with the line, and here we are at 2. That's going to be your skill for I4, finding the constant of proportionality from a graph. You're going to be reading the graph and being able to designate what is the constant of proportionality by using the graph and the skills we've learned so far. Once you've finished this section, section 4, you can move on to the next one, but pause the video now, and when you're done with section 4, you can come back for the directions on section 5. All right, you've finished I4, find the constant of proportionality from a graph. Now we're moving on to writing equations for proportional relationships from graphs, which is section 5. Anytime you're not sure and you just start a new section, if my directions don't make sense to you, or if you want to have another example, always go to Learn with Example and look through what they've posted. So what we're going to be doing in this unit, or this section of this unit, I should say, is writing an equation for the relationship between X and Y. Remember, we did that when we were looking at the numbers on a table already. Now we're finding the numbers from a graph. So this is very similar to what we've already done. Let's go through their example here. The picture and sound electronics store has hired Bill to work in the warehouse. He uses a pulley with a hand crank to lift heavy boxes, or getting it aside to our simple machines. There is a proportional relationship between the number of times Bill turns the crank to lift a box, which will be our X, and the height the box has been lifted in feet, Y. So for every one time Bill turns the crank, you can see it is lifted 1 foot. So this proportion should make sense to us. We're going to write an equation for the relationship between X and Y, and we'll simplify if we get a fraction. Make sure you always read those last parts of the assignment. You can be reminded of your vocabulary here, which will be helpful when I'm teaching, or when another question is asked that asks you to find something. So we're going to go over it. The graph of a proportional relationship is a straight line passing through the origin 0. So this graph here, this line here, shows a proportional relationship as it passes through 0 and continues on straight. A proportional relationship between X and Y can be modeled by the equation Y equals KX. Now remember, when we're using variables, so if we're using these letters in place of numbers, anytime they're written with with 2 letters next to each other, 2 variables next to each other, it means they're being multiplied. When we get into algebra, we start trying to get rid of any signs we maybe don't need to write. So this would be the same thing as Y equals K times X. When you see those 2 letters being written right there, those variables are being multiplied by each other. So we know that Y is always our number that's going up on the Y axis. X is going to be our number that's going up on the X axis, like in this graph, X and Y. So the number that we're trying to figure out is what number can we always multiply times X to get Y without using the graph. This graph helps us make that equation. So the letter K is the constant ratio of Y to X. It's called the constant of proportionality, like we've talked about before. To write an equation, we're now looking at solution. To write an equation for the relationship between X and Y, first find the constant of proportionality. We just did that in the last section. So we start by identifying one of the points on the line. Just like we've been doing, we go to the one time Bill turns the crank, and we go up to see where our line, our graph of proportional relationship right here, right where that graph of proportional relationship intersects the 1 from the x-axis. And right now it's the 1 from the y-axis. So for every 1 time Bill turns the crank, it lifts 1 foot off the ground. So then we're going to calculate the ratio of the y coordinate to the x coordinate. So we take the y coordinate, which is 1, and divide it by the x coordinate, which is also 1. So in this case, we can do the actual math part in our head now that we understand how to do it. So we find that the constant of proportionality is 1 foot per time Bill turns the crank. Since the product, which product just means like an equal sign almost. So since when you multiply these two, so the product, when they are multiplied together, is commonly written without the 1, the equation for the relationship is just y equals x. Like I said earlier, when we try and get rid of unnecessary information when we're doing algebra, just like you don't have to have a multiplication sign here, we know that any variable times 1 is going to equal the variable. So we don't need to write the 1. That's why it's instructing you to just have it be the x. Okay, we're going to go back to practice and look through. This graph is showing the proportional relationship between, let me go up here and actually read it, perimeters of different size squares. So we've had other equations like this as well. So the proportional relationship is between the side length of the square and its overall perimeter. So there is a proportional relationship between the side length of the square in inches, which is our x on our x-axis, and the perimeter of the square in inches, which will be our y. Now it's going to ask us to write an equation for the relationship between x and y. And I'm going to have to write some of that on the document camera, so I'm going to be switching back and forth. Before I switch over to the document camera, I do want to find the first point on the graph where we find that for 1 inch in side length, let's go up and find where our graph of proportionality intersects. It's going to be 4 inches of perimeter in length. So I'm going to take that information and bring it over to my dot cam, and we're going to work through the equation together. All right, we've switched over to my dot camera, and we're going to go from the coordinates that we just found on the graph. For every 1 inch in side length of the square, we know that the perimeter is 4 inches. So from there, we know that since it was a graph of proportional relationship, that we can use the equation of, or we have to, y equals kx, to always come back and figure out what x is if we know the y information. Okay, so the letter k is our constant ratio. As we keep going up and up and up on the graph, k is what we would be able to use to find a number without having to graph it. So we've looked at the graph, we know that we're working with this equation, and our goal is to figure out what we then need to multiply x by in order to find y. Okay, so the first thing that we do is take our coordinates, and we are going to write those as a ratio. So the ratio is going to be y over x, because we want to find out how to get to y from x. So in this case, we're using our y on the top, which is our second number, 4 over 1. And then we can do the division. Okay, so 4 divided by 1 equals 4. So now we can plug that into our original equation here. This is how we found what k is going to be. And we can say y equals 4x. We know that the constant proportionality is 4 inches in perimeter for every 1 inch of side length. And that's going to keep on going. So we could plug in any number to this equation and find out what the perimeter is if we know one of the sides. So if we had a large square that happened to be if it happened to be, let's say the side length was 3 inches instead of 1 inch like it is here. So we want to find out what the perimeter is. So what is y if x instead of 1 is 3? We can multiply that by 3 instead. And in that case, we would know that y, or the perimeter in inches, would be 12. So we can go through and find the perimeter of the box at any time by knowing just one of the side measurements. And this equation that we've figured out based on the graph gives us that information moving forward. I'm going to do a quick aside on how we write 4x instead of multiplying it out or writing the multiplication sign. I've done this in class before, but I don't know that I've done it on one of my tutorial videos for you distance learners. So like I said earlier, when we're using algebra and we write 4x, that is the same thing as writing 4 times x, which you could see how that would start looking confusing because the multiplication sign looks like an x. It's the same as 4 times x, or the same thing as 4 times x. Oops, that's an F. Sorry, I don't know what I was thinking with an F. There we go. So writing it this way is just the simplest form to write the same thing here. You just don't need to use a multiplication sign. So some of the students in class were confused seeing something like this for the first time. Just know that that means multiplying, same thing as these. Okay. I'm going to let you go in and work on doing this in IXL. If you're forgetting how to do it, rewind, go back in the video, look at how we found the y and the x by using the graph. Re-listen to the topic of y equals k times x and how we found the numbers to solve the equation, because you're going to be asked to make an equation that you could always solve for y in the different scenarios, starting with the graph and the basic information. Once you have finished section 5, you can come back and I'll do section 6 with you. So please pause the video now. And then when you're done, at least to 75% in section 5, you can come back and we will work on section 6. Okay, you should be moved on to section 6, which is identify proportional relationships from graphs and equations. We're going to go ahead and look at that together. And we're going to go ahead and use the Learn with Example feature so that we can talk through the vocabulary and the way in which you're going to solve these problems together. So the instructions are showing us select the graphs that show a proportional relationship between x and y. Let's remember what that means. Two variables have a proportional relationship if the ratio of one variable to the other is constant. So if the ratio of the bottom number to the top, if the ratio of the x value and the y value are the same as you move up, that's the an equivalent ratio, a proportional relationship as it goes up. The graph of a proportional relationship between x and y is a straight line passing through the origin 0, 0. So here we have one graph that starts and intersects. I actually could probably keep going this way with the intersection of 0, 0, and it continues moving up. This one, as you see, does not intersect the origin 0, 0. So if we get down to solving, we know to determine whether a graph shows a proportional relationship between x and y, see if it's a straight line passing through the origin. So like I just said, this one is a straight line and it passes through the origin 0, 0. So we know that this graph represents a proportional relationship between x and y. This graph is a straight line, but it doesn't pass through the origin. So it does not represent a proportional relationship between x and y. So when we go to do our work, we're going to say, is it a straight line? Yes. Does it pass through the origin 0, 0? Yes. Is this a straight line? Yes, even though it is a smaller angle and it passes through 0, 0. Here we go. Is this a straight line? No, this shows a different type of information, and you'll see graphs like this in other assignments, but this doesn't show a proportional relationship. This one does intersect the origin 0, 0, and it continues on in a straight line. So we know this one shows a proportional relationship between x and y. Now we're going to work on solving or deciding if these show a proportional relationship. And I'm going to move on to my document camera to show you how to solve one of these. Okay, we have the two equations that we just saw on the screen, y equals 3x and y equals 2x. Now we have to determine if those are showing a proportional relationship between x and y, something that could be graphed through the origin of 0, 0 and would continue on in a straight line. So When we want to determine whether an equation shows a proportional relationship between x and y, we have to see if it can be written as that original equation that we've been working with. You might remember that that is y equals kx. So we have to see, is it written in this format? Well, these two both are. Y equals k, the number we're looking for, times x. Y equals 2, or k, the number we're looking for, times x. So these ones are both written in the correct format, and they would pass through the point 0, 0 and continue on proportionally, because each time for each number of on the x-axis that we keep moving forward, we just would keep timesing that number by, in this situation. My previous video was cut off, so I'm going to go back a little bit. We're trying to decide if these equations, if those, sorry, I'm just trying to set up everything, if those show a proportional relationship. And again, we're going to see if they fit into this format, which both of these do, because they are both, they're both replacing k with a number that would make it so the y-axis point would always increase at the same rate. So the proportional relationship is there, and it would intersect the 0, 0 origin point and keep going. So let me show you something a little more complicated. If you got the two equations, y equals like 7x minus 8 and y equals x, and you had to decide, is one of these equations showing a proportional relationship between x and y? So let's look at this one first. Since this equation has a constant 8 subtracted each time from the 7x, it can't be written this way. Oops, sorry, let me get that back in the screen. We can't write this as this formula, y equals kx, because there always is this minus 8 piece. So that doesn't account for, as you proportionally go up in numbers, you wouldn't be able to subtract 8 from each outcome and always get a proportional response. So this one does not represent a proportional relationship between x and y. The graph of this equation is not a straight line through the origin. So definitely not that one. Let's look at this one. This equation, y equals x, is written in this form, and that is because a variable on its own, like this x, always could have a 1 in front of it. So 1x is the same as x. They're both the same. So in that case, you could have written it y equals 1x, and then it would be in the format here. You can always assume there's a 1 in front of any number. But like we've been practicing, anytime you're doing algebra, you want to eliminate things that you don't need. So we can eliminate the 1 and have y equals x, and it still fits in this format. The graph of this equation is a straight line through the origin. It's one of the similar relationships we've looked at before, where 1 on the x-axis is going to be 1 on the y-axis, 2 on the x-axis is going to be 2 on the y-axis, and so forth. So that's how you're going to go about this section 6, identifying proportional relationships from graphs and equations. And I look forward to working with you tomorrow.